Good afternoon. We're going to go ahead and solve systems of equations using tables and graphs. If you look at the very top, we either have a solution, one solution, or if the line is the same line, in other words, the two equations are the same line, then it's going to be infinitely many solutions. And of course, if they're parallel, there is no solution. We're going to go ahead and start with number one, problem one. So I'm going to make this screen larger. It says, what is the solution of the system? So we're going to have to graph these two on the same graph. Before I do that, I need to go ahead and solve for y. So I'm going to go ahead and do that. So the first equation we have negative 3x plus 2y equals 8. So we're going to have to solve for y. You add 3x, so you're left with 2y, and this is going to be 0 equals 3x plus 8, and then we're going to divide by 2. So our first equation is y equals 3x over 2 plus 8 divided by 2 is 4. That's our first equation. The second equation, we have x plus 2y equals negative 8. We're going to solve for y, so we're going to subtract x from both sides. So we have 2y equals negative x minus 8, and then divide by 2. So y equals negative x over 2 minus 4. So let's go ahead and type these two equations into our calculator. So go to Menu, Graphs. So the first one is going to be Control, Division. So we have 3 over 2 x plus 4. Enter. And then we go to Menu, Graph. Okay, we're going to type in Control, Division, and we have negative x divided by 2 minus 4. And the answer will be where both of them intersect. Now I think the calculator can find the intersection. So intersections, you want to go minimum, maximum, and you notice the intersection is negative 4, negative 2. Now you also notice if we do the table, Menu, we can also see the intersection. So if we scroll to negative 4, negative 4, negative 2, then if I scroll here, negative 2, so you notice the answer to both of them is x equals negative 4, both y's equal negative 2. We're going to do a word problem. It says the diagram shows the birth rates and the growth rates of the two species of sharks. If the growth rates stay at the same time, the rates stay the same, at what age would the spiny dogfish and a greenland shark be the same length? So it says here the growth is 0.75 x, that's for every year. The birth length is 37. Now we wanted to come up with the second equation. It would be 1.5, because that is the growth rate, times x, that's for every year, and the starting birth length is 22. So what we're going to do is we're going to solve this graphically. So I'm going to go to the menu, and I'm going to go ahead and escape. I'm going to go ahead and type in new graphs. So I'm going to type in 0.75, which is the rate of growth per year, plus 37. And right now I'm going to adjust the window. So I'm going to go to Menu, Graph, Function, and I'm going to type in 1.5x plus 22. Enter. So what I'm going to do is I'm going to adjust the window. So I'm going to go to Window, Graph, Window, Settings. And what I'm going to do is I'm just going to play around with this. I'm going to write 50 for right here, 50. And Y, min, I'll leave it like that. I'll press OK. Okay, so that didn't work. So what I'm going to do is I'm going to affect the X value for years. Oh, I was affecting the X already. So let me go to Menu, Window, Settings. That was the X I should have affected. I'm going to go and put in 50 here. So you notice, and by the way, I just made up the numbers. We have the two equations. So what I'm going to do now is I'm going to look for the intersection. Minimum, max. So it approximately takes 20 years. It takes 20 years for it to reach the same length for both species. So I'm going to write 20 years. So after 20 years, they're going to have the same length in centimeters. So it's 52 centimeters. And so here's a way that we can use systems of equations in an actual problem dealing in biology. When do these two intersect? They intersect after 20 years. So we're going to check whether we have one solution, no solutions, or many solutions. Okay, so we're going to go ahead and we have 4y minus 2x equals 6. And we're going to place it in slope-intercept form. So we're going to add 2x to both sides. So it's going to be 6 plus 2x. And then we're going to divide by 4. So 6 over 4 have 2 in common. So that's going to be 3 over 2 plus 2 over 4 is 1/2. So it's x over 2, which is 1/2. Now we're going to go ahead and place the other equation in slope-intercept form. So you have 8y equals 4x minus 12. Divide by 8, divide by 8, divide by 8. So y equals x over 2 plus, and we notice that we have 2 over 8. So that's going to be 1 over 4 since we have 2 in common. So it's 1 over 4. Now you notice, if you just, without us graphing, you notice that the slope is 1/2 and this slope is 1/2. So the two lines have the same slope. So that means that these two lines will never intersect and there will never be a solution. Okay.